Yay! All right. I'm going to give people some time to get on. I know that I'm about 30 seconds early. That's okay. Um, all right. Super excited to bring you guys episode 6 of Impression Five's Science Investigations. For those of you who remember me from week 1, I'm back. My name is Betsy. I'm going to give some people some time to get on. While people are getting on, while we're waiting, I would love to welcome you guys into our science investigation today by asking you guys a question. So if you guys have seen any of our other science investigations, whether it was making a compass with me all the way in week 1, investigating cactus science with Julie, making a hovercraft with Miranda week 3, or exploring acids and bases with Nick during week 4, or just last week making a pan flute with Haley. So let me know if you guys have attended any of our other science investigations, or if this is your first time. So go ahead and let me know in the comments. I would love to know so that we can kind of welcome you guys into our science investigation today. If this is your first time joining us for a science investigation and you're kind of wondering what the other ones were all about, you can always access those videos right here on the Impression by Phase Facebook page, right under our videos tab. So they're all in a beautiful playlist there that you can access at any time. So I am not seeing any. Oh, there's one. I see a hello from Alex. Welcome, Alex. It's really wonderful to have you here today. I hope you're doing well. We've got somebody here who is here for their first time, an 8-year-old and a 5-year-old. Welcome, you guys. Thanks for joining us today. I hope you guys have some fun and that you learned something. If you guys, so you guys will probably notice that I have a wonderful person in the comments as Impression 5 Science Center. That person is named Sandy. So as I'm asking you guys questions, you guys will probably notice that there's a little bit of lag between when I ask the question and then when I'm actually able to see your comments as you're typing them. So if you guys have a question that's really time sensitive, Sandy is there in the comments to make sure that your question gets answered, because by the time I see it, it might be too late, and we want to make sure we answer everybody's questions. So yeah, if you guys want to go ahead and say hi, Sandy, in the comments, that would be awesome. Just so that we can welcome Sandy as well. I'm going to say hi, Sandy. Hi, Sandy. Hi, Laura. I'm so excited to be back doing another science investigation here. Today we have a really cool activity planned. I'm excited to get into it with you guys. I'm actually going to ask you guys another question that has to do a little bit with what we're doing today. So I'm just going to ask you, what's your favorite color? Let me know in the comments. I have a lot of favorite colors, but I would say my absolute favorite color is purple. Specifically right now, it's like a very deep, dark shade of purple that's like a plum color. It's very soothing to me. Some of my other favorite colors include teal, but I like a very green teal, so it's much more green than it is blue. Ilya says hello. Hello, Ilya. I hope you're doing well. Jessa's favorite color is red. Do you have a specific shade of red that you like, Jessa? Or do you like a classic, like, alarm red? One of my friends said that their favorite shade of red is a Ferrari red, which is a very, very bright color red. So yeah, if you're just joining us, let me know what your name is, first of all, and then also if you've been to any of our previous science investigations and what your favorite color is. Alex likes a light red. Nice, but not a pink, right? There's a distinction there. Mom likes Ferrari red. Nice. I'll have to tell my friend that he has a, what's the word I'm looking for? A friend in that opinion? Okay, I'm not seeing any other favorite colors, but I'm sure they will come in as they go. Yeah, no red, not pink. I'm sure they'll come in as we go, and that's okay. I've already introduced Sandy. If you guys haven't had the chance to say hello to Sandy in the comments, please go ahead and do that now. Just as a reminder, Sandy is there to answer any questions that I don't see in time as we're moving through our experiment. So I'm going to go ahead and get, oh, I see another aqua and plum. Those are really, really good colors. That's awesome. So I'm just going to go ahead and kind of get right into what we're doing today. We are going to do a chromatography experiment. Have any of you guys heard of chromatography before? It's kind of a big word, so it's totally okay if you've never heard of it before. You can let me know if you literally have no idea what it is in the comments. If you think you have a guess, go ahead and put that in the comments as well. But I am going to tell you what chromatography is in just a few moments. I don't see any guesses so far, but once again, it does take me a little while to see that. So I'm just going to go ahead and start talking about it a little bit. So chromatography refers to a family of laboratory techniques that chemists use in order to separate out mixtures into their individual components. So I have a definition here to share with you. Right here it says that it is a process used for the physical separation of a mixture into its individual components. So I see that Alex says that she has no idea what chromatography is, but hopefully I have answered that for you now. Now, it still may be a little bit up in the air, like what types of mixtures can we separate with chromatography? What does this really mean? What kinds of things do you need for something like this to actually happen? So let's go ahead and set up our test and see if we can actually get it to work. All right, so the first thing we need to do our chromatography test are a couple different materials. So I'm going to share that list with you now, and then I'm going to show you what I'm using and go over some potential substitutes that you could use in case you don't have any of these things. So first, I am going to use a coffee filter. You can also use a paper towel or any other type of absorbent paper. Anything like that will work for this situation. But I'm using a coffee filter that has been very, very flattened out, but that's okay. You will also need a pencil. I like to use the pencil so I can label my experiment with what type of mixture I'm using. You will also need some scissors. So I have a handy dandy pair of scissors here that I'm holding safely. You will need a black washable marker. I'm using Crayola brand, but you can use any brand of washable marker. Then you'll also need rubbing alcohol or water. So this is rubbing alcohol. The brand or the technical chemical term is isopropyl alcohol. I'm going to use rubbing alcohol because I have it, and it is a little bit faster to run the experiment with rubbing alcohol than it is with water, and I don't want to keep you guys here all day since it is such a beautiful, beautiful day. So I'm going to use rubbing alcohol. You guys can definitely use water. You're also going to need 2 small cups. You want to make sure that they're plastic in case you are using rubbing alcohol. Paper cups probably won't hold up too well to rubbing alcohol or water really. So we're going to go ahead and use these 2 plastic cups that I have here. I'm using 9-ounce cups, so anything around this size would work perfectly. You will also need some sort of eyedropper, or I'm using a pipette that's similar to an eyedropper. You could also potentially use a liquid syringe. But we're going to go over how to properly use one of these in just a little while. So you'll need some sort of dropper that is able to transfer liquids back and forth. Then you will also need some sort of clip. So I'm using a small binder clip for my experiment. You could also use a bobby pin or potentially a paper clip. A paper clip might be a little bit tricky, and you'll see why in just a couple minutes. So I really recommend either a binder clip or a bobby pin. And then last but not least, you don't need a ruler, but I am going to use one just because I like to have straight lines. So I'm going to use a ruler. You don't necessarily need one, but I'm going to use one. That's okay. All right. So I can go ahead and give you guys a minute in case, maybe not a whole minute, but in case you need to gather any last materials. I'll leave the materials list up for now. But I guess I just wanted to tell you a little bit about what chromatography can be used for. So, chromatography is actually used by scientists in the Federal Drug Administration to make sure that, or the FDA, so to make sure basically that different foods and different products are quality tested for consumption so they can make sure that the components are actually what's listed in the ingredients. It can also be used in forensic science to determine what types of mixtures were potentially left at crime scenes. It can also be used actually in antibody testing to figure out. It can be used in antibody testing to help create vaccines. And specifically, it was used back not too long ago during the Ebola pandemic to determine which antibodies worked best at fighting the Ebola virus. So I'm sure that there are scientists right now doing chromatography tests to see how we can deal with COVID-19. So hopefully by now, you've been able to gather up most of your materials, so we'll go ahead and get started with our experiment. I'm going to get this materials list out of the way so that you can see everything that I'm doing. All right, so I'm going to flatten out my coffee filter as much as I can, and then I'm going to take my ruler and just place it right onto my coffee filter like this. Now, I'm going to use my pencil to basically trace the edges of my ruler here. So I'm going to trace along the sides of my ruler to create two straight lines. So I'm going to do one side, and then I'm going to move over and do the other side, and then I will have two lines. I can't see if you can see it. I'll have two lines on my coffee filter right there. Now, I'm done with my ruler, so I'm going to put it away. I can cut on these two lines, and I should end up with just a nice long strip of coffee filter. Got to be careful and pay attention while I'm cutting this coffee filter so I don't accidentally hurt myself. It's very important to watch what you're doing while you're using scissors, especially ones as sharp as these. Okay, so now I have my strip of coffee filter, or if you're using paper towel, you have your strip of paper towel as well. I'm going to set these two scraps off to the side because they might be useful later for a possible extension I'm going to give you guys later at the end of the broadcast. But now, as you can see, I have a strip of coffee filter here, but because my coffee filter is round, the edges are a little bit rounded, and I want one of the edges. So if you're using paper towel, obviously you can disregard this, but I am going to cut one of the edges here to just be straight across. So I'm just going to take my scissors and cut right across the bottom like this. I didn't even do it very well, so I'm going to try again. There we go. That's a little bit better. So now I have my testing strip that's going to hold my marker analysis on here. I guess I didn't tell you what mixture we were actually separating. We're going to see what different colors of ink are used to create the ink that's inside of this black marker. So a bunch of companies will mix together different colors to create the color black, and we're going to see, at least for me, I'm going to see what recipe the Crayola brand uses, and you guys are going to see what recipe your markers are using. You can put in the comments what types of markers you're using if you'd like. I think that would be fun to see. And then you can also put in the comments if you're using a coffee filter or a paper towel for this part of your experiment as well. So I'm going to uncap this so it's ready to go for when I need it. And then to figure out where we need to put the coffee filter on here, you are going to line up this first knuckle right here under your nail with the bottom of the coffee filter like this. You want to make sure you're lining it up with the flat end here. Now, I am just going to put a dot of black marker right above, right above where my fingernail is, and now I know where to put my marker sample. So I'm going to take my marker, and I'm just going to basically stretch that dot out into a line that goes across the width of the coffee filter like that. Are you guys good so far? Do you need me to slow down at all? I know sometimes I have, what's the word? I guess I have the tendency to move through things really fast, so please let me know if you need me to slow down, if you're confused at any part of this. so we can make sure everybody's ready to go at their own pace. All right, so this next part is probably the trickiest part of the whole thing. So if you need some help and you have an adult or an older sibling or a friend or a relative nearby who's ready to help you and you need it, don't be afraid to ask for help. We are going to take one of our cups here, and then we're going to take our coffee filter strip and lower it into the cup so that the bottom of our coffee filter is just barely touching or barely grazing the bottom of the cup. Then you can fold the extra coffee filter over the lip of the cup, and here is where you are going to attach it right to the cup like this. Sometimes the coffee filter, because of static or the way it's clipped, has the tendency to kind of lay flat against the side of the cup or just be really attracted to the side of the cup, but you want to make sure that your coffee filter kind of extends out into the middle of the cup so it's kind of suspended into the middle. Now, I'm also going to take my pencil and label, the top of this with what type of marker I'm using. So I was using Crayola, so I'm going to go ahead and write Crayola all the way up here at the top. It's super light to see, but hopefully you guys can see that. So now my experiment is just about ready to run, but I'm missing one component, and that is my rubbing alcohol or my water. So the rubbing alcohol or water is actually what's going to do the separating. It's going to be able to interact with the black marker and separate it out into those different pigments that we're going to see. So I'm going to use my other cup to pour some rubbing alcohol into it, just like this. And now we have to make sure that when we transfer the rubbing alcohol from here into our experiment cup, that we are super, super, super careful, because if we splash it directly onto the coffee filter or directly onto the marker, our experiment probably won't turn out the way we wanted it to because it might get contaminated. So we are going to use the help of an eyedropper or a pipette to make sure that we do this correctly. Now, pipettes and eyedroppers in a chemistry lab, in order to use them, you must follow the proper pipette protocol, or as I like to call it, proper pipette etiquette, aka pipettiquette. So that is one of my favorite made up words. So I'm really happy to share it with you guys today. So what we're going to do, proper pipettiquette states that you're going to squeeze the bulb up top before you dip it into the liquid, and then you're going to lower it into the cup just so that the tip of the pipette is submerged under the level of liquid that you have. Then you'll release the bulb, and you should be able to pull up a decent amount of liquid into your pipette. Now, when you transfer your liquid into your test cup, you want to make sure that you don't push the pipette against the bottom of the cup and squeeze, because that leads to a ton of splashing, which is super unsafe for our experiment. So we want to make sure instead that we use proper pipette etiquette and we lean the pipette against the side of the cup like this and gently release the liquid into the cup. So for this, we're going to want to pipette rubbing alcohol or water into our experiment cups until the level of liquid in the cup is about halfway to the marker line of our coffee filter strip. Does that make sense? Does anybody have any questions about that part? Now, remember, you want to make sure that you do this very gently so that you don't shake it around and accidentally splash some liquid onto the coffee filter strip. So we're going to make sure that we're really concentrating, just like we do when we use scissors or anything sharp, to make sure that the integrity of our experiment remains intact. All right, I think I just have a couple more that I need to do, and we should be all good to go. I think maybe one more. All right, now I have, so when I typically talk about pipette etiquette, it is so I usually do this activity as part of a forensics program with the Beyond Insight sixth graders in the Lansing School District. And every time I bring up pipette etiquette to them, there's like an audible laugh groan that happens. And I can kind of feel that energy from you guys watching too, somehow virtually. So I'm into that. Also, shout out to the Beyond Insight sixth graders and the one and only Miss Williams. That's a very fun program. So we followed our proper pipette etiquette. We have transferred rubbing alcohol into our test cup. And now we just have to wait. But I want you guys to take a look at your test cup. Do you guys see anything happening to the coffee filter? Is it interacting with the rubbing alcohol or the water in some sort of way? Is anything happening? And if you see something happening, go ahead and put it in the comments. Because remember, I said we needed to have some type of paper that is absorbent. So if it's interacting with the liquid, what does that mean we're seeing happening? So I don't want to move this. I guess I can very gently. No, I don't want to move it too much because I don't want to jostle the experiment around because I don't want to have a contaminated experiment. But what you should see happening is the rubbing alcohol or the water start to be absorbed upwards by your coffee filter strip. I think you can actually see it a little bit on mine. There's like a difference in pigmentation on the coffee filter strip where it's darker at the bottom because that's where the rubbing alcohol is being absorbed. So why do you think that happens? How come rubbing alcohol and water are allowed to absorb upwards against gravity? While we wait for our experiment to run, so I'm going to very, very, very gently set this over to the side. I'm going to show you guys a little bit of a demo to explain how this is able to work. So rubbing alcohol and water are two examples of liquids that have one very important quality. And that is that they have a very, very, very high surface tension. What that means is the water molecules inside of water and the rubbing alcohol, or I'm sorry, I'll just stick with water so that doesn't get confusing. The water molecules inside of water are really, really, really attracted to each other. So that's why when you spill maybe a little bit of water, it kind of clumps together in a bunch of droplets instead of kind of going all over the place, unless it's a lot, then you don't really get the droplets. But those droplets occur because the water molecules are all clumping together because they're super attracted to each other because of something inside of them called hydrogen bonds. So these water molecules are all clumped together, but they still retain their fluidity because they're a liquid. So if you were to poke that droplet, you could still drag it around whatever surface you've spilled it on. Basically, here, the opposite is happening. So sometimes water molecules, rubbing alcohol molecules, any liquid with a high surface tension is introduced to a substance that it is more attracted to than itself. And there you actually see it cling to something else other than itself. So I'm going to show you guys an example in which that might happen. So I have a cup and I have two graduated cylinders here. So these are two pieces of chemistry lab equipment called graduated cylinders. And I also have some food coloring and another pipette. So proper pipette etiquette also states that you should never use the same pipette to transfer two different types of liquids. So I'm making sure to use a separate pipette for this experiment here. I'm going to go ahead and pour some water from my water bottle into my cup here, just like that. And then I'm just going to dye it yellow so that you guys can see it a little bit better. Maybe 2 drops might have been too much, but that's okay. I'm going to use my pipette here to stir it up. And now I'm going to start with this graduated cylinder. So I'm going to set this one off to the side for a moment. So glass, which is what these graduated cylinders are made out of, is actually one of those substances that water molecules are more attracted to than themselves. So I'm going to go ahead and use proper pipette etiquette to pipette this water into this graduated cylinder here. Just like that. And now it may be a little bit hard to see on the camera, but I'm going to get it as close as possible, and then I'll also put some pictures in the comments afterwards so that you guys can see. But if you look up at the top, the surface of the water is not flat. is it? It's actually curved like this. This is called a meniscus. Because the graduated cylinder is made out of glass and it's so narrow, the water molecules are actually clinging up to the glass because of how attracted they are to the glass. And that's what's creating that curve. So when a substance is more attracted to some other type of substance other than itself, that is what's called adhesion. So here, adhesion is very strong in the water molecules and then between the water molecules and the glass itself. This is also what's happening inside of our chromatography experiment. The attraction between the rubbing alcohol or the water molecules and that coffee filter strip, because it's absorbent, is stronger than between those molecules themselves. Now, I'm going to show you an example where the opposite is true. So I'm going to go ahead and set this to the side so I don't accidentally knock it over. And I'm going to grab my other graduated cylinder. This graduated cylinder looks almost exactly the same as the other one, but it does have an invisible difference. And that is that the inside of the graduated cylinder is coated or treated with something called Rain-X. Has anybody heard of Rain-X before? If you think you know what Rain-X is, go ahead and put that in the comments, but I am just going to tell you what it is just to kind of make sure that the lag isn't annoying anyone too much. So Rain-X is a chemical that a lot of people put on the windshields of their cars, which are also made out of glass, because when you're driving in the rain, it's really hard to see sometimes. So when you put Rain-X on the windshield, what happens is it acts as a water repellent. So instead of it really limiting your visibility while you're driving, it just kind of wicks really quickly off of the windshield and you're able to see a little bit more clearly. So knowing that, inside of this graduated cylinder is also coated with the same substance, I want you guys to make some predictions as to what would happen when I put water inside of this graduated cylinder. Do you guys think we'll see a different situation occur? Do you think we'll still see that curved meniscus, or will we see something else? I'm going to go ahead and kind of hide what's going on as I pipette water into here so that you guys have a chance to kind of give me your predictions. So if you need a reminder of what question we're asking, I'm going to go ahead and put it up there too to kind of block what's going on in my graduated cylinder as well. So make sure you're getting your predictions in. Just pipetting some water. All right, let's see. I'm not seeing any predictions yet, but that could also be because I pipetted pretty quickly. But if when the water molecules are super attracted to something, they climb up, what do you think would happen if when they're only attracted to themselves in another graduated cylinder? Do you guys want me to just show you? I'll go ahead and take this question out of the way and move my water cup out of the way and just show you what's going on. So here, as you guys can see, there is no longer that curve that existed in our graduated cylinder. And I'll actually bring the other one up so that you can see that as well. So, as you guys can see, instead of having a curved surface, we have a completely flat surface on this other graduated cylinder. That's because the water molecules here are more attracted to each other than they are to the glass. So here we had adhesion where they were attracted to a different substance, and here we have cohesion where they're attracted to themselves. So in our experiment, we are using the forces of adhesion to run our chromatography test. So let's go ahead, speaking of our chromatography test, let's go ahead and check in with our results. So I'm going to go ahead and unclip from my cup. Ooh, I wonder if anybody did a Crayola marker with me. So as you guys can see, that black marker line is no longer a black marker line. So we've separated out the pigments into pinks and blues, which are the colors that the Crayola company probably uses to mix together to make their black pigment. Now, I actually have something else to share with you guys that I think you guys should try at home. So I happen to have access to a different brand of black marker called Mr. Sketch. It's the scented brand. It smells like black licorice, which is not my favorite scent, but I do like the results of this. So I did another chromatography test yesterday to see if this marker company used a different combination of ingredients, and it turns out that they definitely do. So if I put these next to each other, you can see that the Crayola uses blue and pink, and Mr. Sketch uses a deep kind of like an orangey amber color, and then also it looks like black, but it is a navy blue. I'll go ahead and post some pictures of these in the comments too. So I want to challenge you guys to try this experiment with other types or other different brands of black markers, and then also with other colors that you think are made by creating a mixture of different pigments. Like, for example, purple is made with red and blue, or green is made with blue and yellow. So try to see if you are able to separate out those pigment components in different markers as well. So that is all I have for you guys. I'm going to go ahead and share some ways for you guys to share your experimental results. So I'm going to turn off my screen for a second so that you guys can see that information. So here is some info for how to try your experiment and share. So you can go ahead and tag the hashtag MyImpression5 on any social media. You can also email us at zeller@impression5.org or text us at 517-515-3782. So make sure to tune in next week to see Nick. He is going to be using cardboard automata to explore different types of motion. And then, yeah, the next week after that, we'll also have Haley doing a young child activity. But other than that, that is officially all I have for you guys. Thank you guys so much for tuning in to Chromatography Science with me, and I hope to see you next time. Have a great day, you guys.